Assalamualaikum warahmatullahi wabarakatuh and hi. Thank you for spending your time to watch our video. So my name is NIICE2022, the presenter of today, to present the sustainable natural architectural design for sand restoration as the coastal protection at the beach that is prone to the seasonal storm. So before I present my content, allow me to introduce our team member. So for sure, we are from the UMT, from University Malaysia Terengganu, which is under the Faculty of Science and Marine Environment, which is our main is on the coastal. So the team member is me, Siti Hanani, and also Ala Shakira, which is undergraduate student from the Marine Geoscience. There are also Siti Aminah, Wan Xiaodong, and also Nurin Adina, which is a postgraduate student from the Oceanography Coastal Process. And the last one is our big boss, which is Associated Professor Dr. Effie Helmi Harifing, which is currently a Deputy Director of the Institute of Oceanography and Environment, which is on the NIICE. So let's move to the research background. So here I would like to share the research background of our innovative product. So our innovative product is actually called as the effective sand fences, or in the short form is as the E-fence. So basically, E-fence was functional in stabilizing and also encouraging the dune formation by regulating rate of aerial transport deposition as they are decreasing wind speed by the sand laden wing towards the E-fence. So furthermore, this E-fence is very simple, inexpensive, and also easier to install. So now all of you might be curious about how actually the E-fence can effectively restore the sand dune. So here on this slide, we can see that when the powerful wave and wind come, it will leading the sediment to move offshore and erode it. But with the presence of the E-fence, wind will be prompt to deposit the sand. But how? Because E-fence will be intercept wind-blown sand, causing the sand to deposit behind the E-fence. So for the result, it can effectively form and build the sand dunes. So when coming here, you guys might think, why actually we do this thing? So let me tell you why. So in our country, in our Malaysia, we can see that on the Terengganu beach, there are a very long and beautiful beach that people usually love to go because they want to have fun. They want to go to have some relax. However, when there are rainy season or monsoon season come, and with the help of the anthropogenic factor, can lead in that long and beautiful beach become eroded. Yeah, for sure, the government take actions such as a groin at the UMT and also a rock embankment at the Seberang Takeh. And for sure, at first, both construction bring benefit, which is can reduce the erosion, but in the end, it bring the erosion. Here we can see that with the erosion, it can lead a decreasing of the beach elevation and also resulting in the destruction of the property. Therefore, we come up with the solution, which is the implementation of the E-fence. So this is the aerial photo of the E-fence that was implemented at the Madara, which is on the 30th century. So basically, E-fence are very benefit where it can be restored the dunes naturally, eco-friendly, and most important, can reduce the erosion. So the objective of our study first is to determine the effectiveness of sand trapping in restoring the coastal dune. Second, to investigate coastal damage process after erecting sand fences. Therefore, what kind of the method that we use in order to achieve for both objectives. So this figure illustrates the method that we use in order to obtain for both objectives. So firstly, we use RTK GPS in order to obtain beach profile, which is from the vegetation to the low tide, in order to obtain beach elevation, beach slope, and also the beach volume. Second, we use anemometer in order to obtain the wind speed, which is before and after the E-fence. So after that, we use the compass in order to obtain the direction of the wind. So lastly, we use the numerical modeling, which is by using S-beach. So for the S-beach, we use it because we want to illustrate the situation of the sediment movement after we erecting the E-fence. So for the S-beach, we use the wave from the mic and also model domains such as a grid from the depth 3D. Now let's move on to our result, which is after the implementation of the E-fence. So based on this figure, the green zone actually indicate the area is protected by the E-fence. So based on this result, there are fine sediment was found, indicate that on the area that protected by the events is actually having a smaller wave, which is can bring into the moderate slope, and also height bed level from the numerical modeling showing that the area is actually having restoration and a formation of the dunes. In comparison, on the area that was colored by the red zone is actually the area that was not protected by the events. So there are coastal sediments indicates there are strong wave, and there are flat slope and also low bed level from numerical modeling indicate that the area is actually having loss of dunes. As we can see here, the wind speed tend to become lower when it passes through the events. So to conclude our result, we can say that with the implementation of the events, there are decrease in the wind speed, which is can leading to the dunes restoration, and also it can reduce the erosion as it causes the bed level to changes, which is on the positive way. After knowing that the events actually can work well in order to protect the beach, you might think that the events only can be used in order to protect the beach, but of course it's not. It has many contribution to the society, as we can see here on the slide. With the implementation of the events, it can provide fishermen boat dock. Second, it can conserve marine habitat, it can enhance tourism sector, it can improve the socio-economic sector, and also most important, it can reduce and control the coastal erosion. So this is the demonstration of our project.